This lesson, you've got to understand what we're doing right now. This lesson is to show you how to do the 5 ways to prove a quadrilateral is a parallelogram. There's 5 ways to do it. Alright? And 3 of the ways are just converses of the ways of the statements that we just had in section 5.1. So this lesson is all about the 5 different ways you can prove a quadrilateral is a parallelogram. Alright? The first way, here we go. We're going to do this in lots of colors for you. The first way is by definition. Okay? So the first way to show that a quadrilateral is a parallelogram is to actually use the definition. So what do I mean by use the definition? Well, you actually have to show both pairs of opposite sides are parallel. So we're actually then showing that both pairs of opposite sides are parallel. If you could actually show that, if that could be your proof, then that's enough to show that the quadrilateral is a parallelogram. Yeah, are parallel. So you actually have to show both sides, both pairs of opposite sides are parallel. If you can do that, that's one way to show that a quadrilateral is a parallelogram. Okay? But that's not generally the way that most people do it. The way that most people do it is they choose one of these next 3. All right, these are by far the most popular ways to do it. So we can say by definition. The second way to do it is to show opposite sides are congruent. So the picture would be something like this. Okay, you would show that opposite sides are congruent. So you would show that this side and that side are congruent, and then you would show that side and that side are congruent. If you can do that, then you can say that the quadrilateral is a parallelogram. So here's what we'll write down. We say this: if both pair of opposite sides are congruent, then the quadrilateral is a parallelogram. So then what do we say in the proof? This is what we say in the proof. We say if opposite sides congruent, then parallelogram. That's what we say in the proof. So the second way to show that a quadrilateral is a parallelogram is to show that opposite sides are congruent. Alright, the third way to show that a quadrilateral is a parallelogram is to show that opposite angles are congruent. So the theorem says this: if both pair of opposite angles are congruent, then that's enough to say that the quadrilateral is a parallelogram. And the way that we say it in the proof is this: if opposite angles congruent, then parallelogram. So this is the third way to show that a quadrilateral is a parallelogram. Here we go. Here's the fourth way to show that a quadrilateral is a parallelogram. You can show that the diagonals bisect each other. So here's the theorem. The theorem says this: if the diagonals if the diagonals bisect each other, then we can say the quadrilateral is a parallelogram. So what do we say in the proof? Here's what we say in the proof: if diagonal, D-I-A-G, bisect each other, then basically we say the exact same thing, we just wrote down the theorem. So this is the fourth way to do it. So if you can show that the diagonals bisect each other, meaning that they cut each other exactly in half, two equal parts, if the diagonals bisect each other, then it must be the case that that quadrilateral is a parallelogram. That's the fourth way to do it. Last one. The fifth and final way to show that a quadrilateral is a parallelogram, this is the fifth and final one, is to show that one pair of opposite sides is both parallel and congruent. So what I mean by that is this. So if I could show, like, say for example, this side and this side, this is a pair of opposite sides, the two yellow sides. True? If you can show that those are both parallel and congruent, then you can say it's a quadrilateral. I mean, the quadrilateral is a parallelogram. Well, you'd have to prove that they are congruent to each other by making an auxiliary and drawing a triangle, or it has to be given or something, right? So these are the things. This is sufficient enough to say that quadrilateral is a parallelogram if you can show those two things. Now, a lot of times students will do this. Okay, they'll have this and they'll say, well, that's congruent and that's parallel, so it must be a parallelogram. That's not saying the same thing. Yes, the side that's parallelogram, the side that's parallel also. Yeah, they have to be on one side, okay? So here's what we'd say in the proof. The proof would be this. We would say if one pair of opposite sides is both parallel and congruent, then it's enough to say parallelogram.